So in this lesson we're going to be solving exponential problems using natural logarithms, and it's not going to change too much from when we were using common logarithms. The difference is going to be our base is going to be a form e. So as you can see in this first problem, I have e to the 4x is equal to 80. What we're going to do is we're going to take the natural log of both sides of the equation, and you'll notice that I can take that power, bring it out in front. So I have 4x ln e is equal to the natural log of 80. Natural log of e basically says what power of e is e, and that's 1. So I have 4x equaling the natural log of 80. Divide both sides by 4, and I get the natural log of 80 over 4. Let's move to the next example. Very similar problem, except now I have a binomial up in my power. So again, I'm going to take the natural log of both sides. Oops. And bring the power out in front, so that's 2x minus 3. That quantity is multiplied by the natural log of e, and that's equal to the natural log of 21. Natural log of e is 1, so I have 2x minus 3 equals the natural log of 21. Simply add 3 to both sides, and then that's going to equal 2x. So x equals the natural log of 21 plus 3 over 2. Now we've got a word problem, and it's talking about continuously compounded interest. So I know my amount equals my principal times e raised to the RT power. I can start popping this stuff in. I want to know how long it's going to take $5,000 at 6.25% to grow to $27,000. Now before we had to use a calculator to do this, now all we have to do is take the natural log of both sides once we have our base term isolated. So I'm going to divide 27,000 by 5,000, and that will be equivalent to e to the 0.0625 t. Take the natural log of both sides, which gives me 27 over 5. Take the natural log of that, is going to equal 0.0625 t ln e. And now this turns into a calculator problem where we're just going to take the natural log of 27 over 5 and divide that point by 0.0625, which is going to equal roughly 26.98, which is our time value. Let's move to the next example. We want to know how long it takes to triple an investment if we compound it continuously. Now in this case, we aren't given a starting amount or an end amount, and it really doesn't matter. All we really need to do is say, well, I have some unknown amount, let's call it x, and it's continually compounding at 7.5%, and we want to know how long that's going to take to triple that amount x. Well, that just goes to 3x. So I have 3 equals e to the 0.075 t. Take the natural log of both sides once again. we have the natural log of 3 is equal to 0.075 t. ln e, we know ln e is 1, so take the natural log of 3, divide that by 0.075, and that's going to give us a value of t. And this is going to give us roughly 14.6 years. So finally, we've got a situation where we're given a table with data in it, and we're asked to use a calculator to find an exponential model for this. Now, there's a couple of exponential models. Let's refresh ourselves as to how we're going to plug this in the first place. So we get our calculator up, and what we want to do is we want to go to the Stat, and in Stat we're going to Edit. In Edit, let's plug in the years of 1950 through 1990 and its corresponding data elements. From this point, we want to find an exponential model. So what we're going to do after we've plugged that in is we can quit that screen, hit Stat, move over to Calculate, and if you look, I believe somewhere around 8 or 9, there's 2. We have a natural log regression or an exponential regression. Let's just go exponential since they asked for an exponential. Hit Enter and hit it once again, and you'll notice we have an exponential equation. So if I was going to write this, I would say something to the effect of, let's see, 1.49. See if I can keep this on the screen. I don't think I'll be able to. So we've got 1.49 times 10 to the negative 10th. That's going to be multiplied by the base of 1.02 raised to the x power, and that's going to be our exponential model. Now it asks us to use a calculator to plug in 2050 to this calculated model and find out what our value is going to be based on this exponential equation the calculator got us. So if you remember, now we're going to go to second table set. Make sure your table set is set up to ask, and then we can go to our table from there. And you'll notice there's nothing in this table, and even if I plug a number in, there's going to be nothing in that table because I haven't plugged the equation into y equals. So we have to do that. So we're going to go to y equals, just hit bars, go down to statistics, over to equation, regression equation, and that's going to plug in that exponential function that I had. Now move back over to our table, hit second graph, and we want to plug in the value of 2050 for the year, and that will get us out a y value of roughly 31.37. So this is going to be 31.37. And that's how we go and do that. Here's our set of questions for the day. First two are right in front of you. The third one, I'll scroll down. And here's your third. Answer those and we'll see you tomorrow. Thanks.